In today's lesson, I'm going to explain in a bit more detail how you can work with and manage sub-assemblies when coming from SOLIDWORKS. Although Fusion 360 is based on a top-down modelling approach, when working across multiple teams using standardised parts or using supplier data, you may find yourself needing to create your assembly using a variety of files from a number of different sources. I want to show you the differences between a copied and derived sub-assembly using our single-cylinder engine, and I'll first bring up the connecting rod to demonstrate. Here you can see we are missing some fasteners to secure the main bearing cap to the connecting rod. As we use standardised components across our projects, we have a project containing these components which are accessible to anyone with an invite via Fusion Team. In this case, we'll right click and insert 4 instances of the bolt and nut via the data panel into our current assembly. The first thing we can do is move them into a more appropriate position or leave them as is. Until constrained with a joint, these inserted copies are still free to move in space, although with the revert command you can always send them back to their original position. You can identify a copied instance or external reference as denoted by a chain symbol next to the respective component in the browser tree. A copied instance cannot be edited, which is ideal when working with standardised parts. However, you should note that if the original is amended, these changes will propagate to any assemblies that contain these instances, and any updates will be notified by the yellow triangle symbol. You can break the link of an instance should you need to turn it into its own component for further editing. Copied instances are great for standardised components and checking form and fit, as well as saving on computer resources. Now I want to show you the power behind derived components, although before I do, I'm going to set up a parameter for our bushing diameter and add to our favourites, and I'll show you why in the following steps. We have our connecting rod subassembly with external links finished, and I would now like to add this as a derived component to our master engine block assembly. You have the option to either push or pull a derived component into an existing assembly, depending on which space you are in. In this case, I will push to our master engine assembly by opening the derived command and selecting add to existing design. With derived components, you can select specific design features you want to add to an existing assembly, including individual sketches, bodies, construction planes, or entire components. Depending on how you want to reference design features, what you select can help simplify your design process and also save on computer resources where possible. One of the other main benefits of derived components is the ability to derive parameters. At the bottom of our pop-up dialog box, you'll see the option to select favourites or form components. Going back to the parameter I created before, I want to derive this favorited bushing diameter to our main assembly, so I'll select this option, hit OK and select our main engine assembly, and now we have our connecting rod as a derived component in our main assembly, as denoted by the arrow symbol. You can also see that the joints are maintained, although, as per my joints and motion studies video, you will need to apply a joint to the main assembly to stop the entire component from moving in space. With derived components, you can amend these as you would with any other component, although any changes will only be reflected within that specific assembly and won't affect the original, with the edits captured in the timeline. If you want the changes to be reflected across all instances, then you'll need to edit the original design as you would with a copied instance. Now I want to create the piston component using this derived conrod, and as always you can do so in a number of ways. In this case, I'll show you how you can use derived parameters. Before we begin, I'll open up the parameters dialog box and you'll see a section that separates derived components and their respective parameters. I'll favourite the bushing diameter parameter again and we are good to go. I've already created a base outline of our piston, so I will insert, then break the link to make it editable. And to finish, I need to create a piston pin boss for our piston pin, which ultimately is respective of our connecting rod bushing diameter. To ensure the diameter of this boss matches the ID of the connecting rod bushing, I can simply sketch on the face and use the derived parameter from the con rod subassembly. Now when I go to update the original parameter, this will also be reflected in the piston referenced in the assembly. Now I can finish the surrounding geometry, add some joints, and we now have a similar result to the previous model where all components were designed in one assembly. This lesson was a brief introduction to help you with your transition from SOLIDWORKS and the differences between a derived and copied component when working with subassemblies. Thanks for watching, and I'll see you in the next one.